Hello everyone. Now we are learning for the semaphore. Semaphore we have seen at the last lecture that it is having two processes, entry section processes and exit section processes. We can call the entry section processes are P process or wait process or sleep process or down. All are the same. And again V process, signal, wake up are the for the exit section processes. Okay, here entry section, exit section, critical section. Okay, we have seen the two types of semaphores. Binary semaphores. Binary semaphores having semaphore variable value as a 0 or 1, and counting semaphore ranges from -infinity to +infinity. So what is a basically semaphore? Semaphore is an integer variable which can be used to shared variable as a shared variable to prevent rest condition. S नावाचा एक इंटिजर व्हेरिएबल आहे आणि ते आपण यूज करतो आहे आपल्या क्रिटिकल सेक्शन मध्ये एंट्री करण्याच्या प्रोसेस मध्ये. So two types of semaphore, the binary semaphore and counting semaphore. So firstly we will see working of a binary semaphore. Binary semaphore having values 0 or 1. Value 1 implies process can enter into critical section. If yes is equals to 1, process can enter into critical section. If yes is equals to 0, process have to wait to enter into critical section. Okay, so for the binary semaphore, wait process, the code for wait process is like this, and code for the signal process, this is for entry section and this is for exit section. If a process wants to enter into critical section, then initially S value is equals to 1. If a process wants to enter into critical section, it should decrement, it should firstly check and it should enter into critical section, and after entering it should decrement S value. For example, this slide shows the working of a binary semaphores. So P is an entry section process and V is an exit section process. So suppose this is a critical section. Critical section, we are now studying binary semaphore. Okay. So firstly, suppose P1 process is there. Initially semaphore value in the binary semaphore is 1, S equals to 1. P1 wants to enter into critical section. S is equals to 1. So P1 can enter into critical section. So P1 enters into critical section. And after entering into critical section by executing P process, P1 have to decrement value from 1 to 0. From 1 to 0. Okay. So P will enter into critical section. Initially S equals to 1. Then after entering into critical section, one value will be decremented to 0. So at this time, another process also wants to enter into critical section. Suppose here process P2 wants to enter into critical section, but the process sees that S is equals to 0 now. So P2 can't enter into critical section. P2 have to wait. P2 have to wait until S becomes 1 again. So it will wait. So now P1 is executing its critical section, and after completing its critical section code, it have to execute exit section code, that is VS code. Okay, V code. After during exit section, P1 have to again change the value from 0 to 1. Firstly, listen carefully. Firstly, initially S is equals to 1 was there. Critical section was available for P1. P1 come, then after entering into critical section, S value will be decremented to 0 by P1. Then after executing critical section during the V code, it will again increment 0 to 1. So S equals to 1 means critical section is available. So now P2 can enter into critical section easily and it also execute its code. Okay, so binary semaphore value will be switched from 0 to 1, 1 to 0. Okay, this is a simple code for the binary semaphore. Okay, if S equals to value equals to 1, then it have to assign to 0 and vice versa. Okay, simple things, binary semaphore. So now we will see counting semaphore. For the binary semaphore, S value will be from 0 to 1, 0 and 1 only, but counting semaphore it will between minus infinity to plus infinity. You can take. So little example of counting semaphore. This diagram will clear your concept of counting semaphore, how the counting semaphore works. Before that, this is a binary semaphore. It ensures the mutual exclusion because at a single time only one process can enter into critical section. Okay. If S equals to 0, then no other process will enter into critical section. It will wait. It will wait until S will become 1 again. So mutual exclusion will guarantee in the binary semaphore. But in the counting semaphore, more than one processes can enter into critical section. We will see the example of counting semaphore. Suppose this is by execution of a counting semaphore. Initially, semaphore value is equals to 5. Example. They have taken the example. S is equals to 5. So, firstly, critical section S equals to 5. P1 comes. P1 comes and it will decrement 5 value to the 4 and enter into critical section. Okay. Again P2 will come. After coming P2 will also decrement 4 to 3 and it also enter into critical section. But while entering they have to execute P section. In that P section 5, 4 decrementation will be happen. In the P section I am telling about P section. Okay. So again firstly P1 will come 5 to 4. P2 will come 4 to 3. P3 will come again 3 to 2. P4 will come 2 to 1. P5 will come 1 to 0. Okay. Now until now it is okay. 5 process will accommodate in the critical section. Okay. But after that semaphore value is now 0. After that P6 process come. So here P6 process comes but semaphore value is 0. So now critical section is full. Now no other process can enter into critical section. So P6 will try. P6 also decrement the value from 0 to -1, but it can't come into critical section. It have to wait in the block list or suspended list. Okay, in the block list or suspended list. So again P7 also comes. It will also try, but it will decrement -1 to -2. But it can't come. It can't come into critical section. It have to wait in the block list or suspended list. So why after 0, why any processes can't come in the critical section? Because the code of counting semaphore implies that if the value is less than 0, then it have to suspend. Okay. This is a code for entry section. This is a code for exit section in the counting semaphore. Okay. What we have seen? Binary semaphore and counting semaphore. Okay. Thank you.